Alright, concept D is going to be focusing on how to calculate and reflect significant figures. In our previous lesson, remember we talked about how to count sig figs. Here we're going to now apply it further with calculations. By the end of this lesson, your goal should be to get the basic understanding of how to reflect the correct number of sig figs when calculating whether it's adding, subtracting, multiplying, or dividing. Now, why do we need to go about doing this and thinking about this in our calculations? So we can't just be aware of the precision of a single measurement. We also have to know how that precision is reflected in our answer when we use it to calculate. Whether it's calculating density, we have to reflect the precision of our mass and volume measurements in our answer. So it's crucial that the result of a calculation does not imply or suggest a greater precision than any of the individual measurements and the equipment that was used to obtain those measurements. Just a little refresher that's in your note packet. I'm not going to go over it. Just make sure you know your place values. It will make it a little bit easier for communicating your explanations in class. So addition and subtraction have its own rule that it follows for their calculations. Multiplication and division, which we'll do in a couple of minutes, have a separate rule. So just make sure you keep the two and you distinguish between what calculation you're doing and what rule is going to follow. So when you are adding or subtracting, the answer should contain as many decimal places as the measurement with the least precise decimal place. So if I look at two numbers, the tenths place is more precise than the ones. So the 8.92.3 has a greater amount of precision in the tenths than it does in the ones. So here in example A, I'm working with three values of length. One is measured to the tenths, the hundredths, and the thousandths. So what does this mean in terms of our answer? Well, when I plug these three values into our calculator, we get 54.664 centimeters. I can't leave it there. This is showing too high of a degree of precision compared to our measurements. So remember, when adding in this case, we want our answer to reflect the least precise place value of the least precise number. So our tenths place has the least amount of precision than our hundredths or thousandths. So that means that my answer is going to be rounded to that tenths place. So I focus on the tenths place. The one to the right of it is 5 or greater, so that means I round the tenths place up to 0.7. So our correctly rounded answer is 54.7 centimeters. Alright, in our example B, we're going to subtract the two value and notice that the first number is only to the hundredths place. There's no decimal. Those ending zeros do not count. Okay, so the 7 is in our hundredths place. The 7 in this case is in our tenths place. When I subtract these two values, I receive this number of 6,621.3 milliliters. Again, this is representing a precision that is much more precise than our actual measurements. So if I am here subtracting, hundreds place is less precise than the tenths. That means my answer has to be rounded to the hundredths place. So here, hundreds is the least precise. I'm going to round my answer to the hundredths as well. Here is the hundredths. To my right is a number 4 or less. So that means I keep this number at 6. So that's why it's 6,600 milliliters. Alright, see if you can pause this for a little bit or maybe watch one or two examples, pause it, and then try out the rest. See if you can start to do a little bit of this on your own, at least identifying which place value you need to round to. So, number 1, plugging this into my calculator, I get 5.6. However, the answer should be rounded to the hundredths place. I have precision to the thousandths and hundredths, so that means my answer has to reflect to the hundredths. That means I'm actually going to add a 0 into that hundredths place. Remember, zeros at the end of a number with a decimal are significant, so placing that 0 there is an important step in reflecting the precision. For number 2, I get 12.49. I'm subtracting. I have a number to the tenths and to the hundredths, so I want my answer to be rounded to the tenths, which is less precise. That means then that my 4 is in my tenth spot. Next to it is a number 5 or greater, so I'm going to round that 4 up to a 5. So 12.5 is my correctly rounded answer. For number 3, I get 2,380. My precision, I have to the tens and to the hundreds place. That means my answer is going to be to the hundredths place, which is where my 3 is right now. Next to the 3 is an 8, which is 5 or greater, so I'm going to round that up. So I get 2,400. Not 24, but 2,400. And then for the last one here, we get this in our calculator we have to the ones and to the hundredth spot. That means then that the ones is less precise. So my answer rounded to the ones, which is where my 7 is. This is 5 or greater in the tenths place. That means I round my 7 up to an 8. Okay, so some basic math skills in terms of rounding. The tougher part is determining where you need to round to, referring to the precision of the measurements. All right, our other part of this is multiplication and division. When two measurements are multiplied or divided, the answer should contain as many sig figs as the one with the least number of sig figs. We're not concerned with place values. We're concerned with counting sig figs when we multiply and divide. So with these two numbers being multiplied, I have 4 sig figs and 3 sig figs. Okay, when I plug this into my calculator, I get this amount of centimeters. Remember, I'm multiplying, so I'm concerned with the least precise amount of sig figs. If my least precise one has 3, my answer can only have 3. So I'm going to round to 204 centimeters, which contains only 3 sig figs. In this example, I get two numbers that have each 2 sig figs. That means my answer has to have, in this case, 2 sig figs because they're equal to each other. However, when I plug this into my calculator, I get 10. Remember, right now, I only have 1 sig fig showing here. That means I have to round this technically to 10 with a decimal point so that it can shows the 2 sig figs that are in my measurements. All right, so here's 4 other examples that I want you to, again, if you feel good about this now, pause it. If you're still a little iffy, watch 1 or 2 examples before you pause it, and then I'm going to go through them with you. So for number 5, in my calculator, you get 54. Answer should be rounded to how many sig figs? Well, 4.50 has 3, 12.00 has 4, so I need at least 3 sig figs in my answer. Right now I only have 2. So that means that I need to add a 0.0 at the end of it to correctly show the 3 sig figs in the precision. For number 6 in my calculator, I get 1.54. In my numbers, I have 2 sig figs for 11 and 3 sig figs with a 0.140. So I only want 2 sig figs in my answer. So I'm going to count over from the left and show that I have the 1.5. Make sure you still round that 5 to the correct place because this 4 is less than 5. I keep it at 1.5. All right, for number 7, we're dividing. We get 0.375. I only want 2 sig figs in my answer because of that 4.5. Now here, you're going to see that the 0 is not significant, so I'm looking at the 3 and the 7. I'm going to round that 7 up because of the 5 that's to the right of it, so I get 0.38, which reflects the 2 sig figs in my division calculation. And finally, for number 8, I get this larger number. However, I only want 4 sig figs. Okay, here, just be careful. You can't just write 1,752. Because you still have to have a 0 placeholder in this spot so that the number is pretty similar. So you should get 17,520. Again, this 0 needs to be there, but because there's no decimal, it's not significant, so it doesn't affect those 4 sig figs. All right, so that's it. You made it through some calculations involving sig figs. We're going to go over this a lot, not just tomorrow, but over the next 2 days so that you have time to practice it. And get better at it and improve. So make sure you write down any questions that you may have, and we'll go over a couple examples tomorrow before you go and practice independently. So you are all set, so come to class prepared.